Okay, calculate an estimate of the distance travelled by Yestin's car in the first 80 seconds of his journey. So we're going to use the graph. When they want an estimate of the distance, it's simply the area, okay, underneath the graph, okay, the area. And it says here you must consider the speed of the car when t is 0, 20, 40, 60, 80. What they've done here is they've helped us, they've given us what we call ordinates, okay, and this will help us create the sort of trapezium strips then, which is what I've done here. So at those times, okay, to 80, drawn lines up, and it actually creates a trapezium, okay, loads of trapezium. So if I turn it around, you might see it better, okay. So you can see here my first trapezium up here, okay, so I'll draw my line up to the curve, okay, when 20 seconds, okay, and you can see then these two sides are parallel, aren't they, okay. So that's what you need for a trapezium, one pair of parallel sides. I joined that up then so you can see then my complete trapezium, okay, and I've done the same then for the next strip here, okay, there's my complete trapezium, all right, and they are parallel there, all right. So if I work out the area of each of those trapeziums, I'll roughly then have the area for underneath the curve, okay. It's not perfect because you can see here the curve goes like that, yeah, whereas my trapezium sort of like goes above it and then underneath it, okay, but it'll give me a very close, okay, estimate. So the formula, don't forget, for trapezium, okay, area of a trapezium is given on page 2, okay, in the exam, but that's it there. So what I'll do is I'm going to label each of these now. You can label them A, B, C, D if you wanted to, okay, and we'll work them out separately. So area of A, okay, will be half. Now your A and B are the two sides that are parallel, so it'll be 10 there and 15 here, right? So you've got to add those two, and you've got to times it then by the height between the two parallel sides, which is going to be 20 in this case, yeah? There's always going to be 20 in this question. So if we work that out, we've got then in here, well, 10 and 15 is 25, and then times 20, okay? So work out in the bracket first, and we get that. And we've got to work this out then. Now, what you can do, don't have to go in that order. You could do half times 20 first, which is 10, and then times it by 25, so 250. So it doesn't matter the order you multiply in. Let's deal with these two first. Multiply them, give 10, and times it by that. Okay, order's not important. So with B then, same again, right? Now I know I'm going to have 15 for my A, okay, because my A, remember, is the common side here, which is this side I used before. Okay, so that belongs to this trapezium as well. And then B then will be that number there, which is 25, okay. Again, then I'm going to times it by 20, because that's the gap between them, the height. So I get 40 then times 20. And then half times 20, again, right, which is 10, and then times it by 40, 400. C then, so I'm going to start off with 25 for my A here, and then this side then is 30, all right, times 20. So I've got half times 55 times 20. So half times 20 is 10, times 55 is 550, and then D, half, well I'll start off with 30 for my A, because that's 30 there, and actually that's 30 there, isn't it? We end up with a rectangle really, don't we, there? Okay, so yeah, 30 there, times then 20, so that'll be half times 60 times 20. Half times 20 is 10, times 60 is 600. Add them up, okay? So add the zeros, add then the units rather, which are all zeros, add the tens, which comes to 10, so carry the 1, and then add the hundreds. So we've got 6, 11, and the 6 is 17, and the 1 is 18. So I'll double check that there. Yeah, 18. Okay, so we've got 1,800 there. It says then, hence calculate an estimate of the average speed of Yestin's car for his entire 120-second section of his car journey. Okay, well, entire 120-second section, we've only considered the first 80 seconds, haven't we? To get an average speed, we need the total distance, don't we? Remember, speed is distance over time, okay? So the speed for the whole journey, the average speed, will be the total distance divided by the total time. Okay, now, we know so far 1800 meters, isn't it, in the first 80 seconds, up to there. So they want the whole journey though, so we need to consider this as well. But you know what, with this here, we don't need to do trapeziums, if you think about it, because that's just one big rectangle, isn't it? We can just see this here, one big rectangle. It's very close, isn't it? Okay, because it's straight at the top, it's horizontal at the top, so we just simply need to work out the area of that rectangle there. So we've got 40 going across here, haven't we? And we've got a height then of 30. Okay, so 40 times then 30 will give me 1200. Okay, 4 times 3 is 12, add the zeros. So the total distance will be the 1800 from earlier plus the 1200, and then divide it then by the total time, which is 120 seconds. Yeah, so this comes to 3000 divided by 120. Now what I do then is I cancel those zeros, okay, and then we need to see how many times 12 goes into 300, or you could just keep simplifying. You could halve top and bottom, so we get half of 300 is 150, half of 12 is 6, keep halving, half 150 is 75, half 6 is 3, and 3 actually goes into 75 then. Okay, you work that out 25 times, right? So the actual average speed is 25 meters per second.